If data fails the teacher's t-test, you can just force it to take the test again until it passes. Haha. Also have this cute little cartoon with the teacher's distribution instead of a student's distribution. So let's go ahead and get ready to perform a t-test. Hypothesis tests for means are like those for proportions, except we're working with means instead of proportions. Now instead of having a p, I have mu, and it's the null value, not the statistic from the data, but what the hypothesized value is. Your alternate hypothesis has to do with how the null value is different from this. Either it's greater than, less than, or just not equal to. Remember to identify what the parameter is in context. So let's go ahead and look at this example, and we'll do state. This is the coffee machine example that we did a confidence interval for. And we are supposed to get 10 ounces coffee, but the amount varies slightly from cup to cup. And here are the amounts from a random sample of 20 cups. Is there evidence that the machine is shortchanging customers? So they're saying shortchanging. My null is that I'm getting 10 ounces like it says, but my alternate will be that it's less than 10 ounces. And here I have it in context. The population mean is 10 ounces of coffee per cup. The population mean is less than 10 ounces of coffee per cup. Now the plan is similar. Our name is now a one sample t-test for the mean. And we still have the large normal condition like we did for confidence intervals, and still has to be greater than 30. Or the population can be approximately normal. Again, make a histogram or box plots or something to check that out. Histograms are usually the best. We still have the random condition, or if we're told that it's representative, that'll work. And we still have, if there's no replacement, we have the 10% condition. That one doesn't come up as much as you think it would. All right, so let's go ahead and do state and plan for this example. We have a company has set a goal of developing a battery that lasts over 5 hours. Based on the sample at right, is there evidence they met their goal? So I want to be over 5 hours, so that's my alternate. My null is that it is 5 hours, all right? And my alternate is that it's greater than 5 hours. So our procedure is a one sample t-test for the mean. And for random, they didn't really tell us. So we're just going to have to assume that they took a random sample or that it is at least representative. And sometimes you just have to assume. For the large normal condition, I went ahead and did a histogram. While the sample size is not large, it's less than 30, the histogram is not strongly skewed. And there are no outliers, so we can go ahead and use the t-test. Finally, do. Do is slightly different. We're using t instead of z. And our formula is x bar minus mu over the standard deviation for a sample, the averages of a sample. Then you use your alternate hypothesis to determine how to shape the student's t-distribution to show what probability you're seeking. Now remember that your alternate hypothesis determines what probability you're looking for. So we're going to go ahead and start with the one-sided hypothesis where we are saying it's less than, that mu is less than some number, all right? And we're going to shade to the left. So this would be what we're shading. Our p-value is that the t-score is going to be less than on the less than side of that. So our left boundary is negative infinity because that's where that starts, and it goes all the way to whatever t-score we got. For a two-sided hypothesis, we're saying that it's either further away to the left or to the right. So we're going to have a left side that's shaded and a right side that's shaded. So we have both of these. And we will get a t-score. Let's say I use this one, whatever number that is. And I will find the probability that it's over here, but multiply it by 2. How do I do that? To find this probability, my left boundary is still negative infinity. My right boundary is my negative t-score, whatever that is. And here, by the way, that is also a negative t-score, or whatever. Actually, yeah, it will be a negative t-score. All right, and then finally we have the other one-sided, the right-sided alternate hypothesis, that it's actually greater than. So we're going to shade to the right, and our p-value is going to be the probability that our t-score is greater than this. And our left boundary is our t-score, and this time our right boundary is positive infinity. So if you run TCDF instead of normal CDF, that will spit out the probabilities for you. So calculating probabilities for one sample t-test, you're going to do second distribution. Scroll to TCDF. You're going to enter in the values for the left t-value and the right t-value and the degrees of freedom, because remember, the distribution depends on how many degrees of freedom there are. So you have the lower boundary of the shaded area is the lower, the upper is the upper boundary of the shaded area. DF is the degrees of freedom, which is n minus 1. And that returns the probability for getting the statistic you got within the specified cutoffs and the degrees of freedom. Conclusions is exactly identical. If the probability is low, it's a surprise to get that when we reject and state there is convincing evidence for our alternative. All right, and that's pretty much what we say. All right, if our p-value is high compared to whatever our alpha is, and typically it's 0.05 if it's not given, it could be 0.01 or 0.10. But if our p-value is higher than our alpha, then we fail to reject the null and state that there is insufficient evidence for our alternative. And this is what our conclusion would look like. So let's go ahead and do and conclude for our hypothesis test. And we're going back to the coffee example. Now, I did use one var stats to get these, my mean and my standard deviation from my sample. And I know the sample size is 20, so the degrees of freedom is 19. I calculate my standard deviation, and I get 0.0444 because I take the original divided by the square root of the sample size. Then I calculate a t-score, which would be, or my test statistic, if you want to call it that. So it's my sample value minus the hypothesized mean all over the standard deviation for the average of a sample. And there's my t-score. And I can just go ahead and plug in T19 is less than that. I do TCDF with negative 1,000 and negative 3.49, and I would get 0.0012. So my conclusion is our p-value is quite low, 0.0012. It's lower than typical alphas. So there's strong evidence that the mean amount of coffee dispensed by this machine is less than 10 ounces. Now, there is a shortcut to actually perform the t-test on the calculator. First of all, if you have data, enter the data in the list by pressing Stat and Edit, just like before. Put your data in list 1. Press Stat and scroll to t-test right here. And select Data right there. Press Enter. Select your mu naught, in this case 10. Select List 1 for your data. Make sure your frequency is 1 unless you actually do have a frequency list, in which case you'd use L2 probably. And select the form of mu that matches your alternative hypothesis. So if we went ahead and showed you on the calculator, here's the t-test for our set of data. There we go. T-test, data, change this to 10. And we're actually going to list 1, so I can hit second list 1. Well, second and then list and then hit 1. And make sure, I want to make sure I'm less than, because we're saying less than 10 ounces. Come down, and this time I'm going to hit draw. And I'm not going to see a large part shaded because our p-value is so low. And the t-score, see it's at negative 3.49 there. And that's very low p-value, so you see very little shading going on. And one more example, we have the company with the battery. So let's go ahead and go back to that and do the do and the conclude. So again, I'm going to put this data in a list and do one var stats. And here are my numbers. I calculate my standard deviation and I calculate my t-score. Now, typically when I'm looking at solutions on the AP scoring guidelines, they actually have this all down here, and that's fine if you do it that way. We're looking for the probability greater than because we want it to last over 5 hours. So I just did TCDF of 0.7387 to infinity, 1,000 in this case, and got 0.238. So our p-value of 0.238 is higher than typical alphas. It's very high. So there's not really any evidence, there's insufficient evidence that our battery life exceeds 300 minutes. So it does not appear that the company has met its goal.